Okay, so in the last video, we had done t-test paired for two means. So this time we are doing single factor ANOVA. So assume that we have a data for three tape suppliers that we are considering. And this is the distribution of the weights it can carry along various observations. So when we do a single factor ANOVA, the idea of doing it is to arrive at one of the pointers for taking a decision as to whether there is any statistical significance around the differences between the data sets or not. And this can help us to take an informed decision. Okay. So let's start with the exercise and then it will be easier for everyone to understand. So if you go to the data analysis pack, the very first analysis tool is the single factor ANOVA. So here we are supposed to put in a few values which will help the exercise. So in the input range, we will take all the values, including the header row generally, because then it becomes easier to read the data. And because we are choosing the header row, also tick this box, labels in the first row. Okay, and we have this data is anyways grouped by columns, so we let it be. The output range we don't need in a new worksheet. We can probably do it here itself. So I'll put it in this cell and press OK. Now, the moment you do that, the single factor ANOVA table is right in front of you. And we can now, some of these measures are pretty simple to kind of validate. So let's do that also. So if you look at the means of these are 30 observations for each of the tape suppliers. The sum is nothing but you can just validate it by the sum function. 293.13, 290.23, and 295.48, which are these three sums that you see on the table. Same way you can do the average also. So average is, you can take 9.77, 9.67, and 9.85, which is what you get here. Variance basically measures the volatility in the data. And we can do var.s, or let's see with var.s if it gets you to the number. Variance for a sample. So 0.27, 0.13, and 0.13, which is here. Which means that tape suppliers 2 and 3 per se are having almost similar volatility in the data, but tape supplier 1 has more volatility. Remember, volatility is always a measure of risk. Now, the other thing that you need to look at is the p-value. Here, the p-value is 0.27, and it is statistically insignificant. Since the p-value, it basically, if the p-value was less than 0.05 or up to 0.05, that denotes statistical significance. And we reject the null hypothesis. But here, since the p-value is higher than greater than 0.05, we accept the null hypothesis. Now, what does this mean? Accepting the null hypothesis in this case means what? Basically means that there is marginal or little difference between the weights that these tape suppliers can carry. In fact, that's very visible if you look at the means also. Means, agar aap means dekhoge, so you will see very marginal difference. In fact, if you take the range between the min and the max, if you do that, max minus min, it is 9.85 minus 9.67, which is 0.18 kgs, which is 180 grams actually. 180 grams would mean what? Maybe 3 apples or 2 apples and maybe 4 oranges. Not even 4, 3 oranges actually. So that negligible is the difference between the tape suppliers. And if because it's marginal, that's why the p-value is higher and vice versa, which indicates that there's marginal difference. So if these population means are considered or deemed to be almost identical. So statistically, what they are trying to say here, this ANOVA is telling you is that statistically, there is not much difference between the tape suppliers 1, 2, and 3. But the question here is, will you take a decision based on just this single factor ANOVA or not? Now it depends. How big a deal is it for you for this particular difference? If the difference is, if 180, if a difference of 180 grams is something that means a lot for you and for your business, then probably you would not just restrict to, or rather, if the difference is it is a big deal for you, then maybe you can it basically negates the result of this test, right? Because we are accepting the null hypothesis. But in reality, your business says that 180 grams is quite a difference, then probably you might want to consider other parameters like the price, the quality differences amongst the tape suppliers, etc. But if the difference is not a big deal, and if you want to rely only on that, then the results of this particular single factor ANOVA will be really meaningful in helping you to take the decision. So the extent to which this can contribute to your you taking a decision could vary from being one of the guiding forces to the guiding force. And that's how a single factor ANOVA will help in this exercise.